What is this complex foreign idea of quantum computing? How does it even work? Well, fear not, because after today you will be a quantum computing expert. So let's start with the basics. What does quantum mean? Well, quantum generally refers to the study of the wacky behavior of very small objects, such as molecules, atoms, and subatomic particles like protons, neutrons, and electrons. As you can see here, quantum computing is trying to relate this to our modern computing world, turning our classical computers into what are known as quantum computers. So what are the advantages to these quantum computers? Well, for one, they're definitely faster. They're much, much smarter. They're overall cheaper to produce. But most importantly, guys, come on. How cool does a quantum computer sound? Like, I just want one of those things. Too bad, though, they're still being developed. However, just look how happy that guy looks, just dreaming about it. Come on, don't you want that to be you? So how do quantum computers even work? Well, to understand this, we first have to understand how classical computers work. Now, classical computers are actually a lot simpler than many people think they are. All they do is receive a set of instructions in the form of zeros and ones and interpret those zeros and ones into something that we can understand. Now, these zeros and ones are known as bits. The first device to do this was known as a Turing machine, and a Turing machine is a basis for every modern computer nowadays. Now, as you're about to see here, all a computer does is receive a string of zeros and ones as the input, and then produce an output into something we can understand, such as these smiley faces. Now, this is great and all, but what happens when the string of zeros and ones get really long? A quantum computer aims to fix this by removing the zeros and ones altogether. How do we do this? Well, we have to get rid of the bit system and instead switch to a more efficient practical system of qubits. Qubits are different from bits because they can be both 0 and 1 simultaneously. That seems impossible, right? But the way they do this is using a concept known as superposition, which will be explained later. And what we do is we extract a value of either 0 and 1 over and over again from one qubit using a measurement barrier. This means that one qubit can perform the same amount of operations as, let's say, 1,000,000 bits. So how can qubits be both 0 and 1 at the same time? Well, to understand this, we're first going to have to go over some basics of quantum physics, such as wave functions. Wave functions are useful because they show where an electron has a high probability of being and where an electron has a low probability of being. We need to know this because electrons are not in one definite place. They have a high probability of being in one place and a lower probability of being in another place. So we can have a pretty good idea most of the time, but we can never be 100% sure. Now, using this concept of wave functions, we can show a wave in superposition. Superposition means that an electron has an equal probability of being at point A and point B at the same time. And with qubits in superposition, we can create quantum computers. Now, how does this work? Well, if a qubit is in a superposition of being both 0 and 1, we can manipulate this value to get either 0 or 1 extracted from the qubit. And that might sound confusing, but the way we do this is by another process that I'm about to explain, known as entanglement. So entanglement basically is when one qubit manipulates another qubit. In quantum physics, entanglement is when two waves get entangled with each other and change the position of one of the electrons. So if we have wave A and wave B, as you can see, wave A is higher than wave B, so when they get entangled, wave B will move up to where wave A is because wave A has a higher probability than wave B. Now we can use this concept for qubits if we have a qubit that's 0 and 1 and a qubit that's 1. We are going to use this qubit that's 1 or qubit B to manipulate qubit A to get our desired outcome. So as you see here, when qubit A gets entangled with qubit B, qubit A will possess values now of 1. This is because qubits are like electrons in the fact that they can be manipulated by other qubits. And this fundamental concept is the foundation of quantum computing. Thank you for listening.